But with that, I will start. All right. So yes, Apache DataFusion is a top level Apache Software Foundation project. I'll talk a little bit more about what that means in a few minutes. And I'm going to explain basically what it is. And I'm going to start by explaining what it is by explaining what it's not, right? So this is a classic way to build applications, which is you have your application in blue, and then you build some pre-existing database. I'm focusing on analytics, right, where you're processing and crunching data. In this case, you would pick, you can pick a database like ClickHouse or DuckDB or ones that are very common, but they basically have a set of design trade-offs that have been made for it, like a specific file format, a specific type of way to do queries, specific integrations, all that sort of stuff. And for many use cases, that's actually great, right? You have a prepackaged solution, it's all integrated, it all works great. But you're basically stuck with the design decisions that those implementers made, which is fine. However, DataFusion is a little different, right? It's not a full featured system like that. Instead, it's if you wanted to build, if you want to have much more control over how your data system is created. So if you, for example, want to pick and choose which file formats you want to use, how you want to integrate it, how you want to manage the system, how you want to do merging, for example, or compaction. And if you need, for the use cases that need that lower level of control, that's where people end up using DataFusion. And I have a whole bunch of other use cases that I'll describe later on. But that's basically the point. So the point is, who's the user, right? The user is really people who are building these data intensive systems, not the people using the data intensive systems. To kind of drive it home, there's, if you wanted to build one of these things, what are your choices today or before DataFusion, really? The first one was you embed a database like I just showed, right? The second one, you can actually do this. You can actually fork an existing, like a lot of those systems are open source, right? So if you need to add special systems, there's several, I don't know if anyone's in this room, but there's several DataFusion users that started this way. They forked either Spark, or they forked Trino, or they forked DuckDB, and they had modifications because maybe they needed special join algorithms or they needed a special file format or something. The challenge that you find typically with doing that is that you can do it, but often the upstream moves and does stuff that you don't really have any sense. So maintaining that fork is very, very challenging. And so we've had several people not do that. And you can actually, there's a couple of blogs. Yeah, Bauplan wrote a blog about that. There's another company called Canner that wrote something about it. And then also, of course, you can build your own query engine from scratch, but that's a very expensive undertaking, which I know because I've done it a couple of times. So it's very expensive. And of course, the fourth option is DataFusion. You basically start with something that works basically for all your cases, and then it's got the APIs purposely designed to not be as painful when you want to upgrade. It's not painless. I would be remiss if I said that, but it's basically easy to extend, and it's designed to do that rather than just being an afterthought. All right, this is a feature list. I'm definitely not going to read it. The takeaway, you can read the slides afterwards. I'll publish them online. The takeaway is it basically has all the features you want, right? It's very fast, embedded OLAP engine. It integrates with the ecosystem very well, and it has all the goodies that you would expect out of a modern SQL analytic engine, including file format support directly for Parquet, CSV, JSON, Arrow, and a bunch of other stuff. Again, I can talk about that at length, but I don't want to because I don't want to be used all the time. The other thing that I wanted to highlight that's actually very cool that I think we're going to hear a few talks about tonight is the third-party ecosystem. So this is not just the core DataFusion stuff that's sort of managed by Apache, but there's a thriving ecosystem around DataFusion. And in particular, some of the authors of these are in this room, but we've got like a library to add distributed execution. We're going to hear about that tonight. We've got a library of basically table connectors, prepackaged integrations with other database systems if you're building some sort of federated system. We also have, there's like integrating with distributed tracing, integrating with geospatial, all that sort of stuff. So because of DataFusion's sort of API setup, you can build those outside the core rather than have to have one giant ball of mud that has everything in it. Instead, you can integrate these. All right. It also has top-of-line performance. I love showing this. Basically, my thesis is that over time, we're converging to the performance of DuckDB, which is my personal goal. So you can see that, over the course of the year, we're slowly getting faster. I realize this doesn't say quite we're equal yet. We're working on that. We're very close, but we're getting closer over time. So, and that's thanks to a lot of the help of the people in this room. My aspiration for DataFusion, I want to give my nerdy analogy. I'm sorry for those of you who've seen this before. LLVM, but I think it's like very apt, right? And this will give you a sense of like where I want to head. So LLVM is this piece that underlies modern programming languages. So in this case, before, you guys probably don't remember this, right? But back in the dark ages, there was like GCC, and there was basically no other competition for GCC because it was so expensive to build end-to-end compiler toolchain. So if you want a new language, you'd have to both build the front end, but then you'd also have to build all the backing libraries. And code generator and debugger and the whole thing. So what happened was at some point along the way, LLVM was created. It's a reusable library that has all the pieces that you need to build a programming languages that don't really differentiate it. So that's, I think, one of the reasons you've seen a huge innovation, inspiration over the last few years in programming languages is because you basically have this this component that you can reuse, right? So basically any new language that you can think of, Rust, Julia, Swift, all over the place, they all use LLVM under the covers. And so like, what did that actually entail, right? What that actually meant is that the reason you've seen innovation in programming languages is because people didn't have to reinvent the wheel the whole time, right? So I'm basically trying to make the same pitch. Like that's the point of DataFusion with data systems. We do the same thing. Instead of reinventing a vectorized query engine and fast Parquet reader, and instead you use all the existing functionality that we've built together as a community, and then you focus most of your time on building the application features that matter. Like just to give you an example, at Influx, where I work, there's I think 20 engineers working on the database, of which like one of which is me half time doing DataFusion stuff, right? So most of our engineering effort is focused on features, not on the core engine. That's very deliberate. All right, community, I'm gonna go really quick. I just wanted to, it's a big community. Last thing I counted, which was the last month, was 1,000 distinct people, to 22 PMC members, 56 committers. So that basically means there's 56 people who have write access to the repository. And the last version I did this for, there were 114 distinct people who contributed code to the release. That release comes out, by the way, every month and a half or so. So that's a lot of contributions. Please join us. I'm just going to rip through this, but please. ASF, the other thing I wanted to talk briefly, I don't know how many of you know about the Apache Software Foundation, what this is, right? This I don't get paid by the Apache Software Foundation. It doesn't like drive the development of DataFusion. Instead, it's sort of an umbrella organization that helps govern open source projects. I think it's been extraordinarily influential for DataFusion. It's very important. The real benefit that users get out of it is that you get predictability, right? The Apache license hasn't changed in 20 years and it's not going to change anytime soon. And so if you want to build core infrastructure software that people are going to build their products on top of, having this level of foundation is very important. And in fact, you can see around this room, there's a lot of people who would work probably, depending on how you squint, are basically working for competitors. But yet somehow the structure that we have here allows us to all work together in the same underlying infrastructure. So I think that's good. All right. The last thing I want to do is I want to rip through specialized, like basically what people are doing with DataFusion. When I first gave these talk, however many years ago, it was actually quite a struggle to come up with specific examples, but now I just can't fit them all on the slide. So I'm going to go through them quick. The first case that you can probably guess, it's like what I do. There's a bunch of people in the room that do this. There's specialized databases. There's a lot of focus on time series observability, but also we've had people use DataFusion to build bioinformatics. Streaming use cases was very important. Other people have built AI, obviously now AI stuff. So that's kind of the obvious use case you build a query engine around. I think something else that is also much less clear to me is many companies, once you get to a certain complexity level, you have your own custom data infrastructure that does lots of different things, right? It moves data from sources to sinks, it processes it does ETL, it does all sorts of stuff. And I think over time, those get fairly complicated and bespoke. And we see many people using DataFusion for that. And I think there's actually quite a few people doing this that I didn't fully appreciate. And here's a bunch of examples that I would characterize there, or building their products on top of it. So that's another use case. Another fascinating use case that I did not appreciate at all when I first started this was people incrementally. So those data platforms exist. The ones I listed on the last slide are mostly greenfield development, right? They're basically started with DataFusion at the core. There's a lot of use cases. Datadog, I think, might fall into this category too, of you have an existing system, you're trying to improve it some way. You're either trying to make it more efficient, you're trying to reduce the maintenance cost, you're trying to add new features without having to subsidize the implementation. And so they'll actually use DataFusion because it's modular. You don't have to like replace the whole thing in one go. You can start with just like one piece. You could start with the Parquet reader, and then you can then maybe you move to just some particular part of querying or something. And so because it's modular, you can like incrementally roll this out. And so for an existing data platform, that's much more palatable, I think, than trying to roll out a whole new database, right? Like just like swapping a database out is it's one of the more probably scariest things you could do as a production data engineer. At least I don't want to be on call for it. Another thing we've seen people use DataFusion for is data federation. So that's basically writing some sort of query language that queries that can query data that live in other database systems directly. Datadog does that. Spice AI does that. Ren AI does that. And there's several others here. as well. And they often wrap governance or whatever around it. Another thing that's been very popular for people to do with DataFusion is use the execution engine as a way to accelerate Apache Spark. This is basically Databricks' business model was to have a custom, well, early on, the version was you have a custom execution engine for Spark, which is they call Photon, but they charge for it. And so many people have been interested in accelerating Spark performance, but they've been using the DataFusion physical operators for that. Another interesting, fascinating use case that I've seen is that people have used it to actually implement table formats, not just use table formats, read, write from Iceberg, but if you actually want to implement the Iceberg spec or the Delta Lake spec, a lot of stuff in table formats that look like a query engine, like you need to sort the data, you need to merge it, you need to find which are deleted. So they'll often use, I believe last time I checked, we had all 3 table formats in Rust. Use DataFusion. Another thing people have used DataFusion for that I'm particularly proud of is academic research. I'm particularly proud of this, so they try their fancy algorithms or whatever on the research. I'm particularly proud of this one because TU Munich is one of the best database research organizations in the world, and they were starting playing around with DataFusion. So I'm quite pleased that they did that. We've also actually fascinatingly seen many people use DataFusion as like a runtime to power visualizations. So oftentimes you don't think of like a visualization tool needing a query engine inside, but often you need to slice and dice quickly, sometimes in the browser, sometimes not, but you need to basically quickly summarize the data in a way to visualize it. So we've seen a bunch of people embed DataFusion in various applications for viewing, which is kind of interesting. And then the final one is kind of similar to table formats. It turns out when you're implementing file formats, this is an example from Lance, you need to do things also like compute statistics to put in your file. And so it turns out DataFusion gets used for that a bunch too. Oh yeah, and the final one is using for SQL analysis. I know I'm going quick, but so this is a case where like if you have lots of different SQL queries, what we've seen people do is they'll actually use the DataFusion front end and logical plan as an intermediate format to basically effectively do cross-query data flow analysis on top of the queries and how the data flows through it. All right, I think that is probably I'm over time. Thank you very much for listening. And now we're going to switch to our next talk. All right.